Three, two, one, and we're live. Welcome back, everyone. If you're just now tuning in, my name is Rishi Pathak, and I'm the founder of Code the Universe and the lecturer for today's class on Python. So it's nice to see you here if you're just joining. If you're here, if you've been taking one of our lectures before, you know how all this stuff works. I'm just going to be here lecturing. Uh, Puneet, our TAs, I believe, Puneet and Aditya will be answering questions. But however, if you're new or you're just watching this on like a stream or something, don't worry about it. I'll just explain how the classroom sort of works. So uh, we always have during our lectures, we have one person talk and give instruction, and you feel free to ask your questions over in the Python questions channel of the Discord. And again, if you're watching this recorded or something like that, don't worry about it. You can always still go back and ask any questions you have on the lecture in that Python questions channel. But really, yeah. So when I go throughout this lecture, if you have any questions, just feel free to ask there. Additionally, if you're new here again, you may be a little confused because this is lecture two. So some of the concepts here build off of lecture one. So if you feel like you don't understand something or you have some questions, always feel free to ask. But always remember that you can go back and watch the other lectures too. You can watch the first lecture and come back if you need to, and you can always ask questions about that too. So don't worry too much if you're just now tuning in. We're glad to have you. That's what this community is for, to keep people learning, regardless of where you're on, whether you're on lecture zero or whether you're like a Python god. It doesn't matter. The community is for you to learn and get better. However, the fact that you've all made it out here, before we get a deep dive into the code and everything, I sort of want to address that a little bit. I just want to let you know that it really means a lot to me, and I think it really means a lot to a lot of people. The fact that you guys are taking the time here to come to these lectures and learn from us, that's not only meaningful to you as a learner, the person who's able to learn things, but it's meaningful to me because people always ask me like, how do I get started with programming? How do I get better at doing code? How can I become a good coder? How can I do any of these things? Do I have to go get like a degree or anything? And the answer is no. You don't have to do any of those things. The truth is, to become a good programmer, to become good at really anything, it takes you just practice. And the first part of that is just getting started. A lot of people just sit there and think, oh man, coding is way too hard. I could never do it. And that's what I want to show that's not true. I want to tell people that's not the truth. Anyone can learn how to code if they simply take the time and do it. Just like anyone can learn how to do virtually anything. And the first step in doing that is starting. And by coming to this lecture, you've started. And to me, that's like 50% of the work. I mean, 50% of the work at college is just getting up and going to the lecture. And the fact that you're doing that on your own during a time where everyone's just at home and you're taking this opportunity to learn and better yourself, that's just really commendable. And that's awesome. So yeah, regardless of where you're at, I hope you enjoy this lecture. I hope you gain something out of it, and let's get started. All right, so let's talk a little bit about some concepts that we covered during the last lecture. So we talked about variables and print statements and some comments and some other stuff last lecture. But we did touch exactly on how this all sort of gets like works. Like how, for example, does this command like print 3 plus 3? How does it automatically output 6? How does Python know to output 6 over here to the console? And that's a very, very profound question because like, what is this? Like, is it some wizardry or something? Like typing this, is it some sort of magic that makes this happen? I mean, until we really know, we couldn't be for sure. We couldn't understand why this is working like that. So I think it's important to sort of step back a little bit from the actual code stuff and ask ourselves, why is this able to sort of work like this? Why is our code able to actually output something? How's the computer rather able to understand our code? And that's a very good question. So, I mean, you type the code in your editor, you press the run button, and voila, the output of your code comes up on the console. It's almost like magic, right? But then we ask ourselves, how does this process really occur? How is Python able to understand our code? how is it able to interpret our commands? And quite simply, the answer just might surprise you, like on how stupidly ironic the name is. I mean, it's quite simply just the Python interpreter that interprets your commands and runs them. And now you might be like, whoa, 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 what's a Python interpreter, man? We're just getting started here. All right, hold on, let me explain. So when you click the run button on your on this Replit, it actually sets off a three-step process. And you might be like, what's this three-step process? I just type my code here, and then I see run over here. What other processes are there? And so the answer to that is actually when you type your code on Replit and when you press run, there's three different things that happen. So first, your Python code gets converted to a thing called bytecode. And you might be wondering, what is bytecode? I don't even know how to code regularly. How do I do bytecode? Thing is, you don't have to worry about bytecode. Okay, there's a reason we use languages like Python and Java, right? It's so we don't have to worry about all the bytecode. And if you're still confused on what bytecode exactly is, it's sort of some instructions for Python to understand, and they're quite complicated. So, for example, I mean, without going into too much detail, because you can take an entire class on how all this stuff works, but we don't need to go to a deep dive at that level. We just need to understand on a high level how this actually works. So, you type your code here, right? You type your code over here, like for example, print, and then it comes down here and it's converted to a thing called bytecode, right? Bytecode. Now, bytecode is just a set of instructions for the computer to follow. And so what happens is that your stuff over here gets converted over to this thing called bytecode, which are some instructions for Python to actually follow. So for example, and this is not exactly what bytecode looks like, keep in mind, but for example, it might be like this, like, hey, like it might be Python print some random characters, and then some numbers over here, right? This might be, for example, the instruction for print. And again, this is not exactly what it is, but getting in too deep into this bytecode might confuse some people, so I'm preferring to keep this as light as possible as I can. So bytecode, you can just think of some instructions. So for example, I guess a better way to write these instructions might be something like this, like Python output, and then you might do, I don't know, some number output, the sum, and then 3 plus 3, something like that, okay? And of course it's not going to be as nice as this or as readable as this, but just to get a sense of it, this might be something like the bytecode, okay? And then after that, so after this bytecode runs and gets our Python file is converted to bytecode, this bytecode is run by the Python interpreter on a virtual machine. So I might have just thrown like two different big keywords out there, and that might have confused some of y'all. So let's take a step back and understand. With your bytecode, what happens is that it goes over to this thing called the Python interpreter, which is actually sitting on your virtual machine. And so you might have heard of what a virtual machine is. If you haven't, that's all right. So basically what's happening is your bytecode over here, instead of running directly on your own CPU, instead of using your CPU's processes and having your CPU look through this bytecode and try to understand it, what actually happens is that this Python interpreter that is either you downloaded, or if you're on a Windows, you probably downloaded it, or if you're on a Mac, it comes pre-installed. This Python interpreter, what it does is it sits on your computer, creating a sort of virtual computer on top of it, and what it does is it executes this code. And now you might say, what's the point of having a Python interpreter on a virtual machine? Now, why not just run it right onto the computer? And that's a great question. What's the point of having this Python interpreter? And the answer to that is that, for example, this bytecode, there's a lot of different types of computers out there, a lot of different CPUs out there. And each CPU has its own sort of machine code. You have Windows, you have Macs, you have Linux, and then you have all the things in between, all the little flavors of Linux, etc., so on and so forth. What happens here is this Python interpreter, it automatically you're able to install it on whichever machine you're on. So for example, like a Windows machine, you can have a Python interpreter. On a Mac machine, you can also have a Python interpreter. And from that interpreter, you can run your bytecode. So the advantage here of having an interpreter as opposed to running it on the CPU itself is the fact that, hey, your Python interpreter, your Python code rather, is portable, right? So if I write, for example, some Python code over here on my computer and be like, okay, and say I'm on like a Mac right now, so I write some Python code on my computer right here, and so I'm on a Mac, and I write some code here. I do print hello world, and so this is my code that I write, and I'm going to send this over to my friend who's a big Windows guy, for example. So the thing right here, this what bytecode allows us to do is that, hey, we can be like, okay, let's convert this all to bytecode, and then if I send this over to my friend, he'd be able to run my Python bytecode the same. Like, he wouldn't have to change anything, right? He'd be able to run my Python program the same because the Python interpreter sits right there on the virtual machine. It does not require, it's the instructions fed from the bytecode to the Python interpreter are unanimous across all machines. The only difference on each machine is how the Python interpreter is sort of configured on their machine itself. So, I might be losing you if I am. Just hold on for me with a second. Just bear with me. So we're going to do a quick recap about this. What happens first is I write my code here. For example, print, let's say hello world. I'm on my Mac. I write this code. I save it, right? And it gets converted to Python. When I press run here, it gets converted to that bytecode, which are some instructions for Python to follow. And these instructions can be read by a Python interpreter on your virtual machine. And now you might ask, like, hey, then what's the point of this entire bytecode, right? Why even have bytecode? Why not just run directly this stuff that we've written? And that can be for a number of reasons. Maybe we don't want we don't want the user to see exactly what we've written. We don't want people to look into our code and everything. We just want them to run the Python code, for example, and execute the thing. We don't want them sort of taking a deep dive. For example, like an exe, for example, you might see some people, right? They use an exe. The company doesn't give you all the code that they use. They just give you an exe file. That's sort of what this bytecode can be sort of very loosely interpreted as. Just the instructions for the computer to follow, but they'd be sort of ineligible for any other guy trying to read it, right? So that's sort of what the bytecode is, the purpose of bytecode. And the thing with this bytecode is the fact that since we have a Python interpreter which sits on a virtual machine, we can deliver this bytecode to literally any computer that has a Python interpreter installed on it, and it will work perfectly. So whether it's a full-on computer workstation, PowerHorse gaming, you like a PowerHorse gaming setup, or if you're just on a Raspberry Pi, you can still run the same Python code. And that's what makes Python so popular. I don't need to convert everything to a specific machine code designed for either a Mac or a Linux or some other thing. So that's why Python is so popular, and that's why it's so useful, is because it's portable because of these features. So that's cool. So I think like that, and so that should give you a pretty good understanding of how this Python code runs. And if anyone ever asks you, if you don't fully understand everything, that's no worries here. All right, this is just sort of kind of going under the hood. You don't need to know this to code, but I think it's sort of important to just kind of understand. So if like someone asks you, what's happening here in this Python code, why is it working? You can sort of explain to them. Like first, our instructions are converted to bytecode, and then those bytecode run on a thing called on a Python interpreter, which is on a virtual machine in our computer. So I hope you're able to understand at least a little bit of that, if not all of it. But rather, we'll be continuing. I see a few people have questions. Again, ask the TAs. We'll be continuing on to the next topic. All right. So now that we've understood what Python is sort of under the hood, that's cool. We understand. Now let's go on to some more Python code. And again, if this is your first time, and if you sort of want a record of what all you learned today, lecture notes or something, these lecture notes are always available on our website. You can go and just download them for free. And you can, if you're watching this after it's been recorded, then those lecture notes will be on the website. But if you're watching it live, then right now, some of you are watching this live, we will release the lecture notes after the lecture. So don't worry too much about like if you want to like type something down and if you didn't have time to, it's no biggie. We'll release the lecture notes. And all the problems that we go through are going to be on there. All right, so let's dive into our first our section of the day, or our first real Python section, I guess, of the day. Our first code section. That's a better way to put it. First code section, and that topic is none other than conditionals. So if you were at the last lecture, you might remember that we left off sort of right here, right before conditionals. We didn't get too much into it. So let's talk a little bit about what conditionals are. So conditionals are sort of the result of comparison values. Sort of, you might have heard, like, if there's this, I mean, as the name suggests, even over here, like, if there's a certain condition, then we do something. If a certain condition is met, if that condition is met, then we do something. Otherwise, we do something else. So that's sort of what a conditional is. But to truly build up to this idea where we can, take decisions, make decisions based on input, right? Because based on given input, we need to first understand not a simpler, but rather a deeper concept called the true and false operators, or the Boolean. And now you might be like, oh man, what's a Boolean? That's all right, we'll get into it. Let's go slow. All right, first of all, let's check out the following block of code. And if you're wondering how I'm typing so fast as I type these things in, it's because we've already typed out the lecture notes, and I'm actually just copying some of the stuff in right here. Okay, so let's look at this block of code right here. So this first thing over here is like typed like this. So first I type print 5 is less than 2. So you might wonder, how do I read this? So you read it as 5 is less than 2, sort of like a question. Like, for example, if I'm typing something over here, I want to type like a question, I want to compare two numbers, I can do it in the following way. So if I want to check if, for example, let's just say I forgot whether 5 was less than 2, or if I just wanted to check it, I could do it like this. So I could do print 5 is less than 2. And so if this operates to true, so how you can read this is this saying print 5 is less than 2. Or rather, print is 5 less than 2, sort of like a question. Is that a question? So it's either true or false, right? 5 is either if 5 is either not less than 2, or 5 is less than 2. So that can be either true or false, right? And if we execute the program, what we'll see is this actually evaluates the false. So that is the idea of a Boolean. It comes through the idea of comparison. We make a comparison between two different operands, and we use the comparison operators, which are less than, equal to, or greater than or equal to, and so on and so forth, to make a comparison between two different objects. In this case, numbers, right? So for example, if we compare, let's take away this code for just a second and focus up here. So if we compare print 5 is less than 2, we'll get false, right? Okay, that's cool. So what is the true answer here? Let's comment out this code for a second so this doesn't interfere with this. So let's actually try printing the other. Let's try print 2 is less than 5. Or rather, let's not do that. Let's do print 5 is 5 greater than 2. So if 5 is greater than 2, this thing should return true, right? Over here on the output. This statement over here should be false, okay? Because 5 is not less than 2. So when the computer looks at this, what happens is it says, okay, I'm going to look here first. 5 is less than 2. Is that true? No, it's not. It's false, right? 5 is not less than 2, so it's false. And then the computer simply prints false out to the console. So for example, if we run this here, the computer's again going to look here. It's going to be like, oh, is 5 greater than 2? Yeah, that's true. So it's going to print out true. So let's run this over here, and let's see. And so we see over here, first line evaluates to false here, and the next one evaluates to true. Okay, so we're sort of getting some sense of some idea of this comparison stuff. What is this comparison business? It's just returning true or false based on our operator, the result of our operation over here, which in this case is greater than. So now let's say we wanted to check equality, right? There's obviously greater than, less than, and then equal to, right? And so let's say if we want to do that, how would we do that? So your intuition might say, oh yeah, you know what? Let's just do this. Print is 5 equal to 5. But turns out that running this will actually give you an error. And Python even tells you that, hey, cannot contain assignment. Perhaps you meant equals equals. So what's going on here? Let's discuss it. So when you do just equals over here, remember, you're doing assignment, right? This is not actually not asking a question. This is not asking, is 5 equal to 5? Rather, this is sort of the way we assign variables, right? So the way Python's actually interpreting this is it's thinking, we're creating a variable called 5, and we're trying to assign 5 to it. And remember, you can't have numbers as variables, right? You can't do that. So Python is sort of confused. Like, are you trying to, like, for example, if we were trying to make a variable that had 5, we'd do it like this with just one equals, right? X equals to 5. And so that's what Python is reading this as over here. So that's why it's throwing us a syntax error, and it's saying perhaps you meant equals equals. So, the clever idea that programmers had, and they're like, hey, how do we compare stuff without, like, since we already have used the equal sign for something else to create assignment. And if you're confused on what assignment is, check back to the last lecture. We explain it in pretty great detail over there. So the people who developed this code, they're like, hey, well, maybe instead of doing just one equals, what if we did equals equals? And in this case, now this is a comparison. So this is just saying, is 5 equal to 5? That's what this is asking. And if we press run, we get the value true. So that is why we use this double equal sign, in case you're wondering, why this is, if you've seen this type of code before, you see double equal sign. That's why we use double equal sign. And so, for example, we can extend this concept and we could be like, okay, is 2 equal to 5? Let's see if that's true. And let's run it, and we get false. 2 is not equal to 5. And note that we get the same thing if we do 5 is 5 equal to 2. All right, that is just the identity operation there. All right, if one thing is, it doesn't matter on which order you compare these two, they're not equal to each other, right? Okay, so we see it over here, false. Now let's try something else. We can also compare like a double, which is a decimal number, over to 5, right? So we can do, is 5.0 equal to 5? And let's see, and it is true because the values of these are true. Cool, so that's a little bit about how these conditionals, these comparison operators and operations work. They do a comparison and they return a value. And now you might wonder, is there a special name for these true-false values, or are they just regular true-false values? Well, these are actually called Booleans. Okay, these are called Booleans, these true or false. So Booleans are values, are data types, sort of like integers and strings, which are numbers and words respectively. It's like strings of character. Booleans are their own data type, and they can they only have two options, either to be true or false. Okay, so that's what a Boolean is. And you might be like, whoa, that's a pretty fancy word. Where did it come from? And it doesn't matter too much. You can actually go into the originations of this Boolean stuff, but that's what this fancy word means. It just means it's a data type that can either be true or false. Okay, so don't get too confused when you see that. Okay, so can we make, the next question asked right after understanding this is, can we make our own Boolean, or does it have to originate from a comparison operator? And the answer is yes, you can in fact make your own Boolean. So for example, like this, you can do Boolean 1 equals true. And if we run our code, we'll see that there's no errors. Okay, so this works. We can also set another Boolean, Boolean 2 equal to false. But there's one key thing to note here, and it is a mistake that I often made when I was first getting into programming. The true and false in a Boolean must be written this way and must be capitalized. Note that we do not write them with quotation marks around them or anything like that. That would make this a string, right? So we always capitalize Booleans and write them without quotation marks. True and false are keywords. But look at this. Let's make a fake Boolean. So look at this. Equals true. Equals, let's put this as true and false. Notice that this will actually give us an error. This is not how we make Booleans. And if you're wondering why this is like giving us an error, why this is a fake Boolean, it's because these true are not capitalized and the false is not capitalized. So that matters a lot when you make your Booleans. You must capitalize the true and false. Okay, so don't make this mistake of making fake Booleans, because these will get you down in your programming career. So try not to make that mistake. Always capitalize your true and false. All right, let's continue. So we can also make a Boolean sort of with integers. Okay, and this is sort of another topic which isn't super duper like always there in the real world, but it's really good to know. For example, you can make a Boolean with zeros and ones. If you use ones, that is another. That is just a numeric way of saying trues. For example, we do bool equals 1, bool 1, and if we make our boolean right here, basically what we're doing is we're sort of casting this integer to a boolean. And remember how casting works. That's what we're doing in here. And we can say x equals that, and y equals bool of 0. And now if we run these, and if we print these out, print x comma y, we will see the value that these return are true and false. So that's another way of making a boolean. Okay, now as we discussed, the booleans must be capitalized, and I think that pretty much covers it on our boolean stuff. So now that you understood booleans, you might be like, okay, well that's cool. You can make some data types and you can do some comparisons. But come on, Rishi, are you really telling me that all of computer science is this? And when I say that booleans, Boolean logic makes up the vast majority of computer science, I don't mean it in the sense that everything in computer science is just as simple as just writing true and false statements. Rather, it is the power of the simplicity which makes Boolean logic so useful in computer science, right? Because, for example, think about the decisions that you make in everyday life. Those, if you boil them down to each and every individual decision, those are actually Booleans. For example, is it raining outside? True or false, right? And if it is raining outside, do I wear a coat? And if it's raining outside, I will wear a coat, right? So raining outside in that case would be a true or false thing. Like it's a Boolean, right? Everything, if you think about it actually at core, all your decisions are actually made up of Boolean logic, thinking about whether something is true or false, right? It's very binary when you break everything down. And there's some studies actually that even show that that is how our brain works. Like our brain literally does some sort of combination of zeros and ones. And the fact that it is so complex allows us to make effective decisions. But actually, at the core of our brain, it's just a bunch of zeros and ones floating around. And that's why you might even hear, like, oh, computers and binaries, just zeros and ones. This is the foundation right here. It's just trues and false, right? It's on switches, and off switches. And if you're a little confused about what I'm talking about, I just want you to know that everything that you do in life can be modeled by these Booleans, by a collection of true and false statements, okay? And so that's why Booleans are so powerful and so useful to us. And I'll show you one of their uses right now. And so this truly enters on our concept of conditionals using Boolean logic. And the first thing we're going to discuss in regards to that are if-else statements. Now, as I said to you, everything in the world, every decision you make is actually using Boolean logic. And let me illustrate that to you with an example of if and else. Okay, so what are if and else statements, you might ask? Okay, well, an if and else statement is just a way for us to, make a decision based on some given input. So consider the following bit of code. And I'm just going to type this out, and feel free to type this with me. So say we're getting our income from a person. So we all make an income, right? So let's say we are getting our income. And so say we want to get input a user's income. Say we are working on designing a system that tells users whether or not they qualify, for example, for welfare, right? And that's a pretty important topic, But at core, let me show you how this is just made with some Boolean logic and some true and false statements. Okay, let me show you. So let's say we're getting someone's income, right? And we're asking them to input how much they make. So we do, please input your income. Okay, and remember we ask ourselves, hey, do I want to use this as a number, right? Do I want to use this income as a number? And if I do, I need to convert it over to an integer or a float, because as it gets inputted, it will be inputted as a string. And if you're confused on that, check out the concepts in lecture 1. That they should clear it up. Or ask questions right now to the TAs. Okay, so this input right here, it must be converted to either an int or a float, right? Which are decimal values. So, you can make dollars and cents. So in this case, I'm going to do a float. So the user's income will be converted to a float. Now that we've done that, let's get on to the actual if-else part. So if the income, and I'm just making up some numbers here, so this might not be factually 100% correct. If the income is less than or equal to, and that's how you do less than or equal to, 20,000 0.99, right? So that might be the income cutoff. If their income is less than or equal to 20,000.99 or $20,000.99, we need to say print you qualify uh, for food stamps, right? Or qualify for welfare. And if you're wondering what food stamps are, they're a form of welfare in America. And else, if your income is, I guess, if your income is not like 2,099 or less than 2,099, print you do not qualify for welfare. And now I'm sure some of you are like, oh my God, what is this? What is this if else? What is going on? And don't worry about that. That was exactly me when I first learned these too. But there's nothing to panic about. Remember, I got you. All right, so let's understand this. So what happened here? First, we took the user's input, right? And then we ask ourselves if, so let's read this actually like as if we're reading almost like a book. So we're asking if income is less than or equal to $20,000.99, print that the users qualify for food stamps. Else, which means else, print that the user does not qualify for welfare. And now, reading this, you might be able to start deducing, what's going on here. So first, this income is checked, right? This income is checked against 20,099 to see if it is less than. So for example, let's run this program, and let's say my income is $1. I'm a relatively poor college student, and you qualify for food stamps. So what happens is the $1 goes in, it gets compared over here to $20,099, and it says if this value returns true, right? If this comparison returns true, if this comparison evaluates to true, print that you qualify for food stamps. And in this case, our comparison income is less than or equal to 20,000.99. This entire thing returns true. So the computer, what it does is it just substitutes sort of this thing for true. And so since this is true right here, the logic here says if this is true, then tell the user you qualify for food stamps. But a thing can only be, if you think about it, a thing can only be true or false, right? There's no sort of in between. It is binary in this case. You either qualify for welfare or you don't qualify for welfare. There are only two choices. So if your income is not less than $20,099, say you're making $40,000 or $100,000 and you're a really rich software engineer or something, then this will print out you do not qualify for welfare. Let's test that out. That's what this else means. That if this thing over here returns false and this if doesn't run this thing down over here. And so let's try it out. So please input your income. Let's put in, let's say I graduated from college and I started making a lot of money. So I work at Google now and I'm making $200,000. Obviously now I do not qualify for welfare, right? Because of this logic, the way we set the system up. Now that is pretty powerful in and of itself. We're able to decide whether someone qualifies for welfare just using a few lines of code. And so obviously you can see how this would be useful. You could run this through a whole data set of people and you could decide very quickly who qualifies for welfare and who does not. So that is a little bit of of why this might be useful to computing. Why this sort of if-else model might be useful to computing, besides just the fact that, this is how our decisions are modeled. All right, let's move on a little bit. Let's go in a little bit deeper. Let me see. Let me pull up the next little bit of code. But I do believe that the next topic, I just want to show you guys one more sort of example of an if-else sort of statement. And I'm sorry that I'm taking a little longer because this Replit tends to refresh on me. So let's go through one more example of how an if-else might work. So say, for example, back to my rainy day example. So if-else example number 2, right? Let's go through that. So back to a rainy day example, right? Let's say you wear a raincoat if it's raining, and if it isn't raining, you wear short sleeve, right? So that is something that depends on the weather. So for example, we might say weather, and let's put input, right? Let's do input. Please input please say yes if it is raining. So we're asking the user, hey, say yes if it is raining, okay? Or even better, not please say yes, just say, uh, is it raining outside? You're asking a question, right? Is it raining outside? And you're going to take that input, right? And now you're going to ask yourself, hey, do I want to convert this to some sort of like number or something? Do I want to do addition on this weather? And the answer is no. You're just taking a yes or no, so you don't need to do addition or anything like that. So if this weather, right, is equal to yes, and we'll just tell the user answer with yes or no, right? So if weather is equal to yes, we might say, okay. So if if it is raining outside, then we'll say, okay, print, I think you should wear a coat. And for example, else if it is not raining outside, we would be printing. If the user said no or something else, or some like gibberish, we'd say, I don't think you should wear a coat, right? So this is a very, very rudimentary example of how these if-else might be used, for example, with not just numbers. So let's block out, let's just pretend, let's not worry about the income example. Okay, so is it raining outside? So, oh, look at that, that code is not showing up too well. Let us block this out over here. I apologize, looks like my computer is unable to handle the recording software and having Replit open. But let's try it again. So, let's give it a sec. Let us duplicate this tab. And again, I'm sorry about this. This tends to happen a little bit whenever I record on this computer for a long periods of time because the computer does not like that. But let me slow this down and let me exit a couple of apps that might be eating up some data. All right, here we go. We are back working again. Let's see. Awesome. Yeah, it is. Drag this out over here. So is it raining outside? Answer with yes or no. So for example, let's say yes. I think you should wear a coat, right? And if we had said no, for example, or if we hadn't said yes or no, we just said some like let's just type in no for the sake of the program. And if you're able to see, it's all the way over there. No, I don't think you should wear a coat. So that's a little bit about how this if-else works. So this thing's checked over here to see whether this thing evaluates to true. And remember, you read this as is weather equal to yes, and if it is equal to yes, then we do if this thing evaluates to be true, this comparison, and you do print, I think you should wear a coat, else I don't think you should wear a coat. All right, so that's a little bit about how these if-elses work. Now, let's do a task. And if you're sort of new to our lectures here, you'll notice I'm putting up a task right now, and I'm going to give you guys a sort of challenge problem. So please don't just sit back, while you could if you, I guess, wanted to, please don't just sit back and not really do anything. I think these tasks are really useful in that they serve as some guided practice for you guys. So, we don't do too much guided practice besides this and the homework. So by doing this, we'll be able to answer some of your questions and stuff. So please attempt the problem and then ask us if you have any questions instead of just waiting here to see when I type the code. So let me tell you guys the task. So here it is. So the task is we want to compare some integers, okay? We want to take the input of two integers. So let me put this down on enter. You want to take the input of two integers and you want to tell me whether they are equal or whether, let's see the rest of the problem. I don't know why it's not allowing me to see the entire problem. Let's see. Let me just type it. I am not having it today with this copy stuff. Okay, let me just type the problem over here. Okay, so here's what the task is. You're going to take two integers as input, and if you're wondering what those three things are, this is just a multi-line comment, so I can do multiple lines of comment. So you take two integers and input, okay? So for example, you might take IE, you might do 4, you might have the input 4, and you might have 5, right? And your task is to tell me whether the two integers are equal or not, okay? That's your task. Let me put this down a line so that you're able to see it. Whether two integers are equal or not. So, this session, I'm just going to have you guys, since this session is obviously the session, we're just going to do like have you guys like pause the video for a few minutes, work on the problem, and if you have questions, go ahead and ask any of the lecturers, right? Any in the questions channel, and then come back to this and I'll do the answer, because this again is a recorded session, although I've been masking it as a live, so I may have gotten you I may have gotten some of you guys there. All right, let's keep on going though. Let's so yeah, you guys pause the video and return back to this once you're ready. All right, I'm gonna assume that you guys have given it a go at solving the problem and you've tried something out, asked some questions, and now I'm gonna go ahead and do a live solve. So again, if this was an actual class, we would just sort of wait. But again, this is me re-recording lecture 2 because the other file got corrupted. So yeah, let's get through it. Okay, so the task, we look at the task again, we probably real quick, take two integers and input, tell whether the integers are equal or not. Okay, so let's first define the input part. We need to take these two integers as input. So we'll do, we'll say x is equal to input, right? We're going to say in the prompt, we're going to say, please input the first number, right? That. And then we're going to ask, make another variable y. We're going to say, hey, input, please input the second number. And I might be saying, okay, well, remember, like, are we going to be using these as integers? Are we going to be just using these as sort of words, right? Well, the answer is the problem asks, see if these two integers are equal. And, you know, we're told that this is an integer. So the best practice here, since these are numbers, is to just convert this over to an int. Okay? Although, if in this case you hadn't done that, it would have worked, because as I'll explain to you in a second. But the best practice is always to convert it to sort of, if you know what the data type is going to be, always just convert it, typecast it, right? Okay, so now we want to check whether these two integers are equal. So let's do if x is equal to y, right? We'll do print the two numbers are equal. If x else, so else, because there's only one other option, right? Either they're equal or they're not equal, so there's two options. Print the two numbers are not equal, right? So let's comment out this other exercise that we have up here, and let's run this. So this should be our code, and so it's asking us over here, please input the first number. I'm going to do 4, 5. The two numbers are not equal. So that works perfectly. So that is the solution on how we do it. And you might be saying, well, hold up, Rishi, what were you saying about the fact that, hey, you might be able to input you would not need this int over here. And you might have actually done this way. You might have not put the int over here and stuff might have worked out for you. So this might have happened, right? Let's compare it. So if you do 4 and 4, the two numbers are equal, right? So you might be wondering, you know, why is that happening? So think about what's going on here. Let's for a second type stuff out in the comment right after. Let's say, so you put in 4, for example, as your input here, and you don't typecast it. So the computer thinks of it as the word, as a sort of a word called 4. And y is sort of assigned to another word called 4. Now obviously, whether you look at these two as numbers or as words, these two things are exactly identical, right? This is the word 4, this is also the word sort of like the, and if you're thinking like F-O-U-R, not that for, like not a real word, but rather it's thinking, it's not, Python is not seeing this as a true number, rather it's seeing this as a string, right? Or I like to call it a word because it makes more sense to me. So when it sees this, it's like, hey, since both of these things are actually equal, then x is equal to y, you know, regardless of whether you check the word or like you think of this as like a string. So that's why it might have worked. But the best practice is always to convert it over to an int, or the type that you are working with. If it's a number, maybe a decimal or something like that. Okay, so that's why I converted it. But either way, this would have worked too. All right, so, and because I converted to an int because I was told it was an integer. Okay, so that is how this task, the answer to this task. Let's try one more task. This one is going to be just about the same difficulty, nothing too hard. So here's the task. Let me explain it to you. Okay, so write a program that determines whether you should wear a coat or not. Okay, if the temperature is less than 60 degrees, wear a coat, else don't wear a coat. Okay, so sort of very similar to the rain thing that we did up there, but kind of like that. So again, you're gonna write a program and you're gonna take some input from the user on the temperature. Okay, so the user's gonna input some number like 50 or 70, right? And assume we're working in Fahrenheit, for example. And basically, you're gonna say, hey, if the temperature is less than 60 degrees, wear a coat, and if the temperature is greater than 60 degrees, don't wear a coat, right? So else don't wear a coat. So go ahead and take some time and try that problem. Pause the video while you do it. Okay, I'm going to assume that you took a second and you worked through the problem, made some progress on it, and I'm going to explain the solution. So, what do we do first? Well, first thing here is we look at what input we need, right? We want to collect all of our input first. So the program says, write whether it determines whether you wear a coat or not, and I said that you get input called temperature. So let's make a variable called temp. And let's say that we are setting this variable equal to the input of the temperature. So what, please input the temperature outside. And now we ask ourselves again, a very important question. Do we want to use this as a variable or, excuse me, not as a variable, but do we want to use this as a word? Like, do we want to use, is this like a word that we're taking in or like a name or something? Or is this a number? And so temperature obviously is a number. So we want to convert this over to a number, right? We want to convert this over to, let's see. And let's ask ourselves, can a temperature be like decimal? Yeah, it can. It can be 60.5 outside. So let's convert this to a float, which is another word for decimal. So now we have the temp. Now what do we do? So if the temp, again, we make an if-else, right? A comparison. We do a comparison. So if the value of the temperature is less than 60 degrees, so if it's less than 60, we want to do print, please, I would not, let's see, I would wear a coat. I think that's what it said. Wear a coat if it's less than 60. Else, we would say, oh man. Okay, here we go. Print, I would not wear a coat. Cool. And now let's try running the program. Let's again comment out the other stuff. And if you're wondering how to do this fast, a user actually, a guy who came to one of these lectures taught me you can do command if you're on like a Mac as I am, or I think on a Windows control. But do control and then go ahead and hit that slash button, or what the question mark is, the forward. I think it's called forward slash. I always get my backslashes and forward slashes mixed up, but it's the one with the question mark. Go ahead and tap that, and that should get your things commented. All right, and I do believe that is a forward slash, if I'm right, because I think the forward slash points through like this. But anyways, we'll discuss that later. Okay, so this is the answer to that question. And let's go ahead and just check our program and make sure it works. And again, let me just explain what this code is. We take the temperature, then we do this comparison here. If this is true, if it's actually less than 60, we wear a coat. Else, we do not wear a coat. So it's a very there's only two choices, right? So now it's asking us input the temperature outside, and I'm going to say it's 70. It is fairly hot outside. I would not wear a coat. I would not wear a coat. Okay, that makes pretty good sense. Our program works perfectly. All right, let's move on then. Let's comment that out, and let's go on. So we've talked a little bit about if and else statements. But now you might be wondering, hey, Rishi, in the real world, there's not only just two options, right? It's not that I either qualify for welfare or I don't qualify for welfare. There's a lot of middle ground, and that's certainly true. That's 100% true. It's never truly just one or the other. There can often be many decisions between that. So in order to model that line of view in Python, we come up with the idea of an if, elif, else clause. And if you're wondering, what is that? What is elif? It's fairly similar. So let's refer back to our previous example of the welfare. So we took the income from a user, right? Like that. Please input your income, and we compared it to $20,000. And if this was true, you qualified for welfare, or you did not qualify for welfare at this time, right? Now let's extend this. Let's say, okay, if you make between $20,000 to $40,000, well, you don't qualify for welfare, but there are some other financial programs that can assist you. So um, you might say, well, and in this case, I'll just say the keyword. You'd say in code, you'd say that as elif, right? So else if this isn't true, then you check this guy. Else if, and that's basically what you're saying, like, sort of like if this isn't true, this income is less than 20,000. Refer to this, so you'd be like, I think I botched the explanation up a little bit. Let me just try that again. So again, so you have the if and else statement here, and so for example, let's say you don't make between, it's not either just less than $20,000. Let's say you want to make a constraint for $20,000 to $40,000, right? So in that case, you'd use an elif, and let me just do it. I think that's the best way to sort of accentuate the point. Okay, so if your income is between $20,000, so if your income is, let's say, so you might say between 20,000 to 40,000. So either it is greater than or equal to 20,000 or less than 40,000. You would say print you do not qualify for welfare. Financial there are various other forms of financial aid available for you. So that's a little bit long, but it's cool. So, although the user does not qualify for welfare, there are some other forms of aid available, right? So that's what this says over here. So if you make between, so let's walk through this code. So say you made $19,000. That was your income. So right here it will say income is less than 20,000. That is true. Print this can qualify for welfare. Let's say though you made $21,000. Now, so this would be false, right? It wouldn't work here. It would go down over here. It would go to elif, and it'd say, so since this is false, it goes to this else if, right? That's where we get this idea of else if, because it waits for this first condition right here. If this is true, it doesn't run, right? If this is 19,000 here, then this program is done. It ends. However, if the user makes $21,000, then we do else if 21,000 is between 20 and 40,000, right? Then print you do not qualify for welfare, right? And then let's say even this doesn't work. Let's just say this was also false. Let's say you're making $100,000, then it would go down to this else finally, right? So let's say we had $100,000 of our income. So let's say it went up here. 100,000 is not less than 20,000, so that's false. 100,000 is not between this, so this is also false. Now it goes to the else, right? This is sort of the catch-all. In case none of these two work, it says you do not qualify for welfare at this time. Okay? And if you, and you can sort of, if you're wondering, like, can you extend this concept? Can we do multiple elifs? And that is 100% true. So you might have another elif, and you say, so else if the other two fail, I guess, if we have something like, let's see, 40,000, right? So if your income is greater than or equal to $40,000, and X, right? I think when we take our income, oh, I'm sorry, it was actually income variable. I don't know why I typed X. So if your income is greater than or equal to $40,000, but less than, for example, $80,000, then we might say print you do, let's see, you do not qualify for welfare. Please check out, if you need help, maybe please check out financial counseling. If you need help, please speak to financial counselor, something like that. I'm just making something up off the top of my head. All right, so this could be another one. This could be another elif. And now, as you can see, you can have infinite elifs. You can have as many elifs as you want. So each elif would just wait until it was its turn to run, right? So after this income, because, as we said in the first lecture, these Python programs are run line by line. So first this guy's done, and then it comes down to this, else if it's still here, it checks this. Again, else if it checks this. And then at the very end, if all these fail, you have your else statement. And you might say, can I have multiple else statements? Well, the answer is no. Remember, your else statement automatically will just execute when it gets to it because it does not wait. It does not care whether there's no condition on it, right? So it will just execute. And so it'll say, you do not qualify for welfare at this time. So if we run this, for example, and we do your income is, gosh, I don't know why this is not working. Try running this and let's bring that here maybe. Oh, okay, there we go. Say your income is 80. Let's say your income is like 65,000. Yeah, and you do not qualify for welfare. If you need help, please speak to a financial counselor. So each one of these options will give you, based on your wage, would give you different options to look at, like based on welfare. So your outputs will be different depending on your income right here. So that allows us to make decisions in the case where there's more than one, like it's not just true or false when there's something in between. Okay, so I think that concept should make pretty good sense to you. So if it doesn't, always feel free to ask some questions, but let's try a task. So let's do a task. Let's extend the comparison of integers that we did earlier. So task 2.3. Compare some integers and improve upon the previous comparison by including greater than / less than, right? So previously we had our comparison of integers and we said, okay, whether those two are equal to, so on and so forth, and then we just said, okay, if those equal to, then if the two numbers are equal to each other, then we say, hey, that okay, we just print out they're equal. Now, the goal is improve that previous comparison where you're given two integers and you're asked to compare them by including a thing that says if they're greater or if they're less than, okay? So go ahead and try that out and see whether you're able to do that. And yeah, so pause this, since you're probably watching this on the recording, just pause the video and we'll come back once you're ready. All right, I'm going to assume that you've gone ahead, paused the video, and given it some thought, so I'm going to explain how this works. So we want to take in two integers again, so we'll do x, and so actually we'll just name it int1, and we'll say input, please enter the first integer. And if you're wondering what an integer is again, it's just a number like that doesn't have decimal points and all that stuff. Int2 will be input, please enter the second integer. Right, and now we want to convert these two things to ints, right, because we're going to be using these as numbers. And now we want to compare these integers. So if int1 is equal to int2, then we'll print the two integers are equal. Elif, so if these if this is not true, then we check this else if these integers. So again, like if this wasn't sort of clear up here in the other examples, I think I can make this a little more clear here. This else if is sort of like an else statement, but sort of like an if statement. So it's an else statement in the regards that it waits for this if statement to get checked, and it only runs if this guy is false. But it's an if statement also in the fact that it is going to check its own condition, right? It's also checking a condition. So it's not really fully either an if or an else. It's sort of between them. It's an elif. So that's why it's called an elif if you're wondering. Okay? So now we do int1 is greater than int2. So we'll say print the first integer is greater than the second, elif int 2 is greater than, or let's say int 1 is less than int 2, and we'll just say print the first integer is less than the second one. Okay, and so that should improve upon that. And you might say, well, do I need to do an else statement at the end right here? And the thing is, no, you don't need to type an else statement right here, because remember, we've already considered all the possible cases. And so if in fact actually you wanted to change this over to an else statement right here, you could, because obviously a number that is less than the other number is also not equal to it, right? So you could just improve upon it and you just do else right here. So that should save your program a little bit of memory in like not having to do this comparison, but that's not that big of a deal. Okay, so you can do it like this. So if you had the two integers are equal, it would print this. If one is greater, it would print this. Else, obviously there's only one other possibility left. The first integer is less than the second one. And again, you could leave this as an elif if you wanted to. You don't have to end with an else. It'll still work exactly fine. But again, if you just have an else there, because you've already checked all the other possible options, you can have an else there, right? So because there's only three options of the numbers that you can put in. Either they're equal, either they're greater, or it's less. There's only those options. Okay, let's move on. And so I think we've gone through this question pretty well. Okay, let's go on to another task, and let's try to improve the previous dress code example. So let's do another task, which improves upon the previous dress code example. So, task 2.4, dress code. Improve on the dress code program, which told you, hey, what you should wear during the weather. So if it is 60 degrees, tell your user to wear a windbreaker. So previously we said, hey, if it's greater than 60 degrees, we say, hey, man, go wear some short sleeves, have some fun in the sun, right? If it is less than 60 degrees, it's chilly outside, wear a coat. However, if it is equal to 60 degrees, hey, maybe you want to wear a windbreaker, okay? Because remember, our previous program did not account for equality to 60. It just wouldn't work if you put an equals to 60. So go ahead and try that and work with those cases there. So you'll get an input on the temperature again, and if it is 60 degrees, tell the user to wear a windbreaker, and let me just enter it right here. And if it is less than 60, tell the user to wear a coat. And let's see. Oh, not a connection aborted error. Coat. That's the problem with this replit. Sometimes autocomplete's bad. Okay, and if it is greater than 60, tell the user to wear. Gosh. Let's do a second. To wear, 1 second, sorry, where am I? Tell the user to wear a coat, and if it's greater than 60, tell them to wear a short sleeve. Okay, cool. So go ahead and give that program some thought. Go ahead and try coding it on your own. And once we return, we will pause the video, and once we return, we will go through the solution. All right. Okay, I'm going to assume that you paused the video and tried coding it for yourself. Let's go through the solution. So first of all, we want to take the input from the user, right? So we want to make a variable called temp, and let's take an input. So what is the temperature outside? And again, since we ask ourselves, hey, do we want to use this as a number or just as a word? And we want to use it as a number. So we convert this to an int. And let's see, and we'll actually, let's not even do an int, because it could be a float, because the temperature could be a decimal value, so we do a float, actually. All right, let's keep going on. Now, if the temperature is less than 60, we want to wear a coat, right? So let's put that in, temperature 60, less than 60, wear a coat, and our variable is actually called temp. Else if, elif temp is equal to 60, print where a windbreaker, and else print where short sleeve shirt. I apologize if some of my code isn't exactly as good as usual. I've actually stayed up all past night working on some coronavirus research as part of Georgia Tech, and so frankly, I'm pretty tired. But you know, you got to do what you got to do. So, anyways, let's go through this. So, if the temperature is less than 60 degrees, wear a coat. If the temperature is equal to 60 degrees, wear a windbreaker, and else wear a short sleeve shirt. Yeah, man, I am really tired. All right. Anyways, though, so that's how this works, and I think you know, this should be fairly clear to you. So again, if the temperature is less than 60, this is true. Then you want to wear a coat. You want to tell the user else if the temperature. So else if means that there's a condition to be checked. It's not just going to default to and just print out. This condition has to be checked in the else if. This condition has to be met and be true. So if temp is equal to 60, wear a windbreaker. Else wear a short sleeve shirt. Okay. So I think that, you know, I think you guys should have a fairly good handle on else ifs by now by watching that video. But you know, in case you don't, go ahead and feel free to ask questions and high questions, and we'll try our best to answer them. All right, though, let's move on to another section: lists. So, lists. Now, you might be like, "Oh man, this is another terrifyingly hard concept." No, not really. Lists are probably even easier than if else. Okay, so let's go through the idea of what a list is. So, how, I guess you start off and you ask yourself, how do you even make a list, right? This is a list. This is literally it, okay? To make a list, all you do is you type like this. You type these two brackets, which can be found on your keyboard near to the P value. If you see, I mean, the P key. You type that, and you can type 1, 2, 3, 4, 5, 5, 6, so on and so forth, right? And you can have some values in there. A list, in other words, is a collection of values. That's what it is over there. That's why we have a bunch of these values stored. And we can actually give this another variable and say y is equal to that. And if we want to print this list out, we could print it out and see the contents of this list. So if we do print x, oops, these programs are still running, which I'm going to go comment out so they don't run. So we print x, we will be able to see, okay, the list is over there, 1, 2, 3, 4, and 5, for example. And if we wanted to print y, x followed by y, and we could see that also. So, in a second, print code. Fortunately, it doesn't look like it's running. Replit has slowed down again. Let's duplicate this. Tab. Oh, there we go. It worked. So right after 1, 2, 3, 4, 5, it printed out 1, 2, 3, 4, 5, 6. Another list. So as I said before, these lists are just collections of values. And so the values inside the list actually have a special name. They're called elements, and they're ordered by an index. So a list is actually ordered. These numbers have an order. You might be saying, well, yeah, obviously, right? They're 1, 2, 3, 4, 5, 6. But actually, let me do this. Let me rename this 6, 5, 4, 3, 0, -7. Okay, so they don't need. That's not what I mean by ordered being like ascent, like this or something. Okay, it could be. And let's name this instead of 3. This gives 1,000. These can be any values. Okay, and see if you run it, it'll work perfectly fine. By order, I mean that each element here, each sort of number here, has a sort of way of referencing to it. And let me just show you what I mean. So, say we wanted to get the first element in both these lists. So the way we do this is we can do x followed by brackets, and whatever element you want, you go 1 minus that. You type in the number 1 minus that. So say I want the first element. I do x at position 0. So the element at, so how you'd read this is you're saying the element at position 0 on this list x, okay? And so if we print this right here, we print, let's see what we get. Print that, and let's run it. and we'll see 1, right? It prints out 1. So that's what these means. And so you can access other values too. You can access the second value. You can access the third value. And you have to wonder, like, this feels really weird to me, Rishi. Why do I have to call these values like this by one minus them? Like who does that? Why do we do that? The reason this is done is actually in order to optimize memory storage, right? Because if you explore the binary workings behind how these things are actually stored, as I said before, and going down into bytecode and then stuff after that. Like if you're going down deeper into that whole thing there, you will note that everything here, as you said, everything is broken down straight up into binary, like right after, once you have bytecode and everything else. This stuff is all stored. I mean, in Python, it's not necessarily stored as like machine code or like binary code, but everything at core level is eventually stored onto the computer's the virtual machine, or rather the computer's memory. You know what I'm saying? So what happens in that case is that in order to optimize that memory, we actually start counting from 0. So instead of counting from 1, we start counting here from 0. So this is the 0th element. This is the first, second, third, fourth. And if you'd like to learn some more about that, feel free to either ask and apply questions or look it up, because it's actually a pretty interesting topic. But that's why this is done. So that's why we start at 0, in case you're wondering why. But if you don't really care, don't worry about it too much. You don't need to know specifics behind why. Just know that we start down at 0. Okay? Now, let's keep going on. So we can do print other values, right? We can access third value, so on and so forth. And we can run this, and we'll see that it prints. So 1, 2, 3, 4, right? And we can access values on other lists too, similarly. So we can do y at 2. Value at 2 on the list y. So that'll print out 4. Wow, what a coincidence. Okay, so this would be 0, 1, 2. So third value. So don't think of this as a second value, by the way. It's all offset. Okay? Cool. Let's keep going then. All right. Now, so using this format, we can print out each value. Now, we can also print out the entire list, as we talked about. But, what's more useful with this list thing is that we can actually change individual values of lists. So we can do the value at the 0th position, the first value. Let's assign that to be the word 4, right? Or not the word 4. Let's just do Jeff, right? So let's assign the value Jeff to that, and then let's print out that list. Print out X. Oh man, can't seem to type today. Print out X, and we do Jeff 2, 3, 4, 5. Cool. So you can type in values like that. Awesome. Now, what else can you do here? Now, you can change values like this, and by showing this example, I actually wanted to illustrate one other important concept to you, which is that lists need not contain homogeneous values, right? So see how we assign Jeff over here in our list of numbers, right? So you can have a list with a bunch of different values. So for example, you could do this, and this would be perfectly fine. Do that. And now if we print out y at 0, so we make this new list called y, and if we run out, we'll get Jeff, right? So you can have words and other stuff and values. Now, let's ask an interesting question. What happens if we try to access a value that isn't, let's see, let's say if we try to access a position that doesn't exist in our list. So what I mean by that is there's a position 0 in this list, position 1, position 2, position 3, right? But there's only, 4 values in that list, right? So what if you try to access, for example, the 5th value, or say you give an index of 4. Well, let's say you give an index of 4,000. You don't even know what's in this list. So let's say you do that. What will happen? So what happens is you get an error called list index out of range. And what that is saying is that, hey, your list that you try to access, that doesn't have a 4,000 index. All right, so let's keep on going. So what if we try to access a value that isn't there in our list? You simply get an error. As we said, oh man, the E right there. All right, let's keep on going. So now, how can we find the length of a list? And the answer to this is you just got to go and count, man. I'm sorry if that joke wasn't as amusing as I thought it was originally. But Anyways, yes, you don't actually count the values. I'm kidding. What you need to do is you use a function called len. Okay, so use len. This is a built-in function, and so you can type it in like this. And len allows you to find the length of how many values might be in the list. Literally means length, right? So it counts. It says 1, 2, 3, 4, right? And another sort of interesting way to sort of interpret this is that, again, like it starts at 0, right? And it's counting 0, 1, 2, 3. So it's just adding 1 to the last position, okay? That's another way to sort of visualize it if you want to. But anyways, so len counts the number of values in the list. So you can pass in len x, right? And we can print that value out, and it's going to tell you the length of x. And oh, we still have this guy over here. Let's comment out that terrible error. And let's see. And it should give us, oh, my bad, I put an x here. I wanted to find the length of y. Let's see. 4, right? So 1, 2, 3, 4. So that's how you find length. And you can use that for length of x also. And you can get that. Awesome. So that makes pretty good sense. Now, what we use here, again, what this len is called, is a built-in function, okay? It's known as a function. By typing len, we're telling Python, hey, use the function called len, which returns the length of the list, okay? It's like using the built-in function print, again. So when we type in print, we're telling, hey, Python, print whatever is inside here. With len, we're telling Python, go check the length of whatever is inside here, okay? So let's move on. Now let's talk a little bit about how we can insert and remove elements in the list, right? So let's say we want to insert a number or another name into this list. So we want to say insert Rishi into this list of y, right? And then let's print out y again to see the updated list. So if we do that, let's see what we get. Oh yeah, hold up, my bad. I forgot to specify the position. So let's say we wanted to insert my name Rishi at the position 0, 1, 2, 3, 4, or the 4th position, right? So I could do it like this. Insert Rishi at position 4. Let's see, that should do it. String object cannot be interpreted as an integer. Hold on, what is going on here? Oh yeah, the 4 should be like this. Oh, my bad. Let me rewrite this. Oh man, it's been a long day. Okay, so back to insert. So how do we do inserts? We do them like this. We do y dot insert. And so we're calling an insert method on this object, of list object y, and we type in the object that we want to, the position that we want to insert, which would be at position 4, for example, and the object that we want to insert. So I genuinely don't know why it's saying insert object before index there, but I'm assuming it's referring to before this. So that worked, thankfully, and now let's try printing out y. And we'll get that Rishi is in that list now. And so we can actually try this with our other list too, x dot insert, and if we try to insert, let's say let's see, before the 3rd index maybe. Let's try to do that, right? So we'll type in insert Jeff, the 3rd. Then we'll print out x. And so now we can see that we have another Jeff in here. So 0, 1, 2, 3. So Jeff is the 3rd one right there. Okay, so it's inserted at the 3rd position. And if some of you have been noticed, Replit keeps popping up that little thing there that says inserted before. What it's trying to say is actually, okay, so it goes through this before Jeff had been inserted, which is like this list over here. It goes to 0, 1, 2, 3, and it inserts it right before this guy right here. So it puts Jeff in right there. Okay, let's keep moving on. So what's going on directly when we do the insert? So the answer is that insert is actually a method as opposed to being like a built-in function. So you might be wondering, like, hey, why do we have to use a dot here followed by a function? Why was it not just like len like here? Why didn't we do, for example, like, why don't we type it like this? This was my question when I first looked at this. Why didn't we do like something like insert x, right? Why? And so the answer to that is that this insert is actually a method, okay? These are called methods. Insert, for example, is a method. A method is something that is specifically available to our list objects, okay? So these things, these objects, as we call them, these are called objects, and objects are just a fancy word for sort of things. These things right here are called list objects, okay? And a list object, for example, has a method called insert. Now you might be saying, why does why does it not have a method called len? Because the answer is that len is sort of a much more fundamental function, right? Because you can use len with strings, you can use len with many different types of like data, as you'll see. Len is very, very fundamental, but this method called insert is not. All right, you cannot, for example, insert into other data types. There are some data types that cannot be inserted. You cannot have like another value inserted into that data type. So this dot insert means that this is sort of like a method to this. This is sort of tied to this object y, or this object that is of class list. And if this somewhat sounds confusing to you, don't worry about it. It'll make sense just by the end of this lecture. Okay, so we talked about how to use insert. So now let's discuss how to remove an element. So say there's two Jeffs here. I want to get rid of Jeff because Jeff is fairly annoying. I'm kidding, Jeff. But let's just say we want to remove Jeff, right? So we type in x dot remove followed by the parentheses, which indicates that this is a method, and we do x dot remove Jeff, and then we print out x again. And let's see what we get. And the first Jeff is gone. So this remove Jeff, what it did is it removes the first occurrence of that element there. Now, how can we remove the last element of the list, you might say? That's a fairly common question that comes up, right? Many times we have these numbers ordered as like numbers in a hat, for example, and we want to just remove the last element, okay? So how do we just remove the last element? So the reason, and if you're wondering like why we do that, so in many statistics examples, in applications, what they do is they'll have a list, and this will call a list of sort of random numbers, right? Random numbers. And they'll have a list with like a bunch of numbers, which will be like 5, 2, 7, 4, 1, 9, etc., right? You'll have this list. And so you want to sort of, let's see, I believe that it's not like this. It doesn't like the dash. Like that. Okay, so you have this list and you want to remove, for example, like 9, right? So how would you do that? So, and you want to return that. So you want to sort of return this value back 9. So what you do is you do a method called pop, okay? And so what pop does is it returns back your value. And so you do x is your, you store that in like an x, for example, and you just print out the value called of x. And so that should give you 9 because it removes the last value. Okay, and so you might say, hey, well, so couldn't you just do that with this remove? The answer is that remove does not return back that value, okay? So if you tried storing this value, like remove, and if you tried storing that Jeff, you would not be able to store this. So if you print out y, and don't believe that you would be able to store it, and we'll see this one here. Right, see this over here? It comes out as none. So remove does not allow you to store that value. However, using pop allows you to store that last value. Now let's see if we try to pop, and yeah, and so like if we did pop, we would get back that last value. But let's just say you don't want to like sort of remove that last element. Let's just say you want to use. Let's just say you don't want that last element to be returned. So let's talk about the discard method. So discard, one sec, I believe that would be, let's see, we've got pop, we've got discard would go with tuples, I believe. Okay, yeah. Okay, so yeah, we've done, I think we've covered most of the methods of this. However, let's talk a little bit more about it. Let's talk about discarding an entire list, right? Let's say we want to not just discard like a certain element, we want to get rid of the entire list. We want to discard the entire list, right? The way we do that is actually there's a built-in function called del. And what you do is you can have del, and you can put it on a certain list and pass in a certain list, and you can run this, and it will delete. In this case, x is not a list, so I believe this is the list, and it will delete that list. Okay, and so that list will be gone forever. And so then, if you try to access it and print out its values, and you do random numbers and you try to print out those values, that list, you will not be able to print out that list. So it'll say list numbers are not defined. So that's how you delete a list, or how you discard a list. That's what throws away the list. Okay. So that's just you might say, why even have the function like that, right? That deletes it. So the reason is, let's say you're trying to you're making like a huge program, you're trying to save some memory or something, you want to delete like a list that you're not using. That's how you would do it. Okay, so now what if we wanted to sort a list? So say we had this giant list right here, and we wanted to sort it, right? Let's say we had this and we wanted to sort. So we can do z.sort, and that should sort this entire list. And then we can print z out. And if we do that, you will see this comes out over here. Okay, so that is the sort method. And now, what if we wanted to sort the list in descending order? So again, use the reverse method. So do this. Use the reverse method. And again, if you're wondering where I'm pulling this code and copying and pasting it from, we've typed these up already in some lecture notes, and that's where I am copying and pasting this from. These are the lecture notes we used during the actual lecture. Okay, and these are always available on our website, by the way. All right, so now let's talk about appending something to a list. Let's talk about how we could add an element to a list. So say we wanted to add a number to z, right? So we do z.append 3.14159. So that is how we'd add, and then we could print z by doing that. All right, cool. Now we can discuss one more important method, which is called count. Let's say we wanted to count the number of times a certain value occurs in a list. So say we wanted to count how many times the number 5 occurs in this list. And you might say, what's that useful for? Well, let's just say you have a list of names or something. You want to count how many times a certain name occurs, right? So how you could count values is using the count method. So we say z.count, and we pass in a number, which is 5, and we'll say store that as x, and we'll print out how many times that number 5 returns. And we can see it comes out 2 times in the list z. Okay, that's cool. All right, final thing. So remember how I told you that, hey, you could add a string and a string together in the first lecture, and I also told you, hey, you can add 2 numbers together. So for example, 2 strings would be like 40 plus 4. Those would be an example of adding 2 different strings, and we could say that as num. So you can add 2 strings, and then you can also add 2 numbers to each other. So 40 plus 4, right? So, and let's actually have these set. So yeah, print numx. We'll just name that numx because I don't want to print numx. So remember how I told you could do that? Well, the thing is, you can also extend this concept over to lists. This is why this adding in for strings is not directly called addition, but rather concatenation, because we take 2 different values and we add them together, and they're defined differently for both. They're defined differently for both of these things. So they're defined differently for strings, and they're defined differently for numbers. So in numbers, so for like integers, we add this just like how we would add. But in here, we define it so that we just combine these 2 words, right? So, well, lists have a similar definition, okay? So see how it's 44 and then 44, right? So in lists, we have a similar definition. So this concept of concatenation exists in lists. So, in other words, I'm saying that adding is also defined for lists. The addition operand is defined for lists. And so how do we do that? You might be wondering. So let's consider 2 lists, right? Let's say we have these 2 lists. And then we try printing L1 plus L2. So you might be wondering, what is that going to do? What will this return? So if you do this, if you run this, you'll note that L1 and L plus L2 joins the 2 lists together. So we get this entire thing over here, this huge list over here. So that's what adding to a list does. So it's quite similar to adding like a string to another string. where it kind of combines them, squeezes them together. That's what adding. So this is what adding to a list does, and this is called concatenation. Okay, cool. So we've sort of gone down with a list, and for the sake of time, because I noticed we're about, let's see, 1 hour 29 minutes into this lecture, I'm gonna sort of skip out on the task. So you can always check out the lecture notes on our website, and you can see the tasks on there. But for the sake of time in this video, I'm not gonna go through the tasks. Okay, so now let's go to section 4, tuples. And this should be a pretty quick section because now we understand what lists work. Tuples are fairly simple, fairly similar. So tuples are kind of like lists, as in they both store a collection of values. However, unlike lists, tuples are just immutable, or they cannot be messed with. You can't change the value in a tuple. And I think, to me, it really helps to think of a tuple as a sort of a fixed point in space. And you'll see what I mean. So, it's a quick definition on tuples right there. Tuples are kind of like lists, as in they store a collection of values, but however, unlike lists, tuples cannot be changed. So let's define a tuple. Let's say x is equal to, let's do actually my tuple is equal to a tuple like that. So that's our tuple, like an example of a tuple. And let's see. Let's actually start off a little simpler. Let's start off like that. So when you look at this tuple, you might think that, hey, well, this looks really similar to a list. Maybe I can, there are some methods where I can add and arrange some values in here. The thing is, while they both store a collection of values, and while you can access these two values, you cannot mess with a tuple. So you cannot add like another number. You cannot add Jeff to this tuple, okay? So that's why I said think of tuples as these sort of points. So you might have another tuple like this, my tuple 2, and that tuple might be one, like a three-dimensional point in space. 1, 2, 3, right? So these are both examples of tuples. And so that's why I said it helps me to think of this as sort of a point in space, a fixed point in space, okay? Because you cannot add like other values to a fixed point in space because it's fixed there. But as you'll see, this definition sort of quickly breaks down because you might have actually many values in a tuple, you know? You might have my huge tuple, right? And you might have a bunch of different values. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? You can have a lot of values in this tuple, and you can even print this out. So that's why I said that definition sort of breaks down, you know? But it helps for me to think, again, as these are sort of like glued in place. Like you cannot move them, okay? These are there forever, and they're never going to be changed at positions. So now if you do that, you'll see this is a tuple. And when you print it out, you'll notice a list prints out with that little bracket. This prints out with a little parenthesis. So that's how you make a tuple. Okay, let's sort of speed through the rest of this stuff because I don't want to go too much past lecture time. Okay, so tuples, you might be wondering, you know, can tuples store other values? You know, like not are tuples homogeneous? Does that mean that every value in a tuple has to be of like the same group, like all ints or all strings? Because as you said, Rishi, these are fixed points. Well, no, they don't. You can actually have a bunch of different values. So say here's a tuple. This has an integer, a boolean, a string or a word, and a float, so a decimal number. And you can print this out. This is my tuple, and everything should work just fine. So if you notice over here, the tuple prints out and everything works fine. So that answers the question. Tuples can have an arrangement of values, a bunch of different values. However, they cannot be changed, okay? So they're like lists in the fact that they can store a whole bunch of different types of values, however, they cannot be changed, okay? And we'll see this in just a second. So we can actually access the value. As I said, since these are like lists, you might have even guessed that, hey, we might be able to access the value at a certain index in the tuple. So you actually you can do this. So you can do print, and let's give it a second. You can do print my tuple, and let's say we want to access the 0th value, or this first value, the 0th index. This is called an index, by the way, the position. So it says 1. Let's say we want to access the second value. So we do print my tuple, and we'd access the second value, so minus that 1, and you get 1. And so accessing the second value, which is right here, we get true. Okay, so that makes pretty good sense. So that's how you access values in a tuple. And now to the good part. Now to the part where we see how tuples are truly different than lists. Because for now, they've looked very similar. Let's check the statement out. Let's try this. My tuple is 0. Let's say I wanted to change this value to 2. Let's see what happens. Here's the big crux of the situation. And if you don't understand anything else, if you haven't understood anything else in this lecture, this I want you to take away. A tuple object cannot be mutated. In other words, it cannot be changed. Okay, I cannot go inside the tuple and swap out numbers. Okay, I cannot swap out values. If you see here, doing so throws an error. Tuple object or a tuple thing. This is basically saying a tuple thing does not support item assignment. Or in other words, tuple object cannot be changed. Cool. That should really nail it in right there of why a tuple is sort of different than a string. Okay? So that means we cannot use, so this like sort of takes out a whole bunch of methods, right? We cannot use remove, we cannot use append, we could not use pop to pop out for values at the end of a tuple. So we can't do pretty much any of that stuff, right? Like we can't mess with these tuples. So what can we do with the tuple? We can do two very simple things. All right. We can first count the values in a tuple. So we can do my tuple dot count, and we can count how many times a certain value occurs, like that. And we can print that out. So we can say how many times does Jeff come up in my tuple. And we can also do len, some built-in functions on tuples. So len, again, as I told you, len works for pretty much everything. So you can do len of my tuple. And then finally, you can, while you can't discard individual values in tuples, you can discard the whole tuple and obliterate it using this delete. You can just delete the tuple. You can do del and pass in my tuple in there, the del function. And then if you try to access my tuple and print my tuple, just to check if it's been deleted, you'll get an error. And remember, you might use this del in order to delete a tuple that's maybe eating a lot of space or something. My tuple is not defined. Awesome. So and now we return to like the final concept as we talked about with lists. So now, as I told you that, hey, if you have two tuples, if you have a tuple, you cannot make changes to it. But check this out. When I first saw this piece of code, it really did surprise me. So look at this. So if we do, as I said, you cannot change two tuples. But look at this. Look at this sort of cheat method. Let's have a tuple called x and a tuple called y. And let's say we want to return the sum of them, right? We want to return we want to add those two tuples together. Do you think this is going to work? Why or why not? So just stop and pause for a second and think whether this is not going to work or whether it is going to work. Okay, so I assumed you paused it, and let's see it run. And let's see if there's any errors. So no errors, which means everything worked. And let's see what happens to z. So you'll notice that these tuples just got combined over here. These values in this tuple got combined over here onto this tuple right there. And so what that means is that although you cannot edit this individual tuple, you can take two tuples together and you can combine them to form another tuple. So you can, in fact, do concatenation. And notice that it does not break. When I initially saw this, I was like, hey, doesn't this break the rule of changing a tuple? And the answer is that it doesn't. Because notice, you are never directly changing either of these tuples. What you are, in fact, doing is you're taking them and you're combining them to form a larger tuple, okay? You're making a new tuple out of these two tuples. And that, my friends, isn't illegal. All right, I think that pretty much ends our lecture for today because we've gone through tuples. Wow, that was pretty cool. That's awesome. So, cool. We're going to wrap this up here. I'm going to wrap this up here right now. Again, if you have any questions that you have throughout this lecture, go ahead and pop into the Discord and ask the questions. And if you're watching this on our YouTube channel or something like that, our Discord, our website is codetheuniverse.org. Go check that out, and you can always join the Discord over there if you have any other questions. And other than that, I really hope you learned something from this lecture. So, thank you for tuning in and watching this, and I really do hope that you were able to understand something new or maybe gain a new perspective throughout this lecture. I appreciate it. So, until then, please do work on the homework that we've sent out. And if you want to access the lecture notes for this lesson, again, please check out our website. All the lecture notes are available there. And I'm actually just going to type it out right here so you know our website. Go ahead, check out the lecture notes and all the other stuff at codetheuniverse.org. Again, I really hope you enjoyed learning today. Please stay safe. And for me, it's night, so I'm going to go to bed. Peace. Bye.